Okay, this video is going to be about the equations we can use to solve motion problems. So in your physics data book, you'll have 4 equations shown on the left here. And if you want to know how these equations are derived, you can find them in your class notes handout, all the derivations of these 4 equations. In these 4 equations, V stands for the final instantaneous velocity, U stands for the initial instantaneous velocity, S stands for the total displacement, A stands for acceleration, and T stands for time, of course. When we solve problems using graphs of motion, I think it's easiest if we follow some really simple steps to help us solve these problems. First, before we start the problem, we should read it and determine what the problem is asking for. We can then collect all the information the problem gives us and compile it. At this point, we should probably change any units that might not match each other. For example, if one of your units is in meters per second and you're measuring something in kilometers, you need to make a change in your units, otherwise your problem will come out incorrectly. Next, you should select an equation based on what you're given by the problem and what the problem is asking for. Number 4, you can solve the equation before substituting any values in, and I think this will make your life easier in the future. So just solve before substituting in. Last, substitute in the numbers that the problem gave you and solve your problem. So let's do one example problem, and then you'll have lots of practice problems you can do in class. So a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. What is the acceleration of the car? So first off, what is the problem asking us? It's asking what the acceleration of the car is. So we know the problem is asking us to find an acceleration. Next, let's compile all the information the problem gives us. It tells us the car starts from rest. So this tells us that the car's initial velocity is 0. It's not moving when it starts, 0 meters per second. We're also told that the car accelerates for a total time of 5.21 seconds, and that over this time period the car has a displacement or a distance covered of 110 meters. Okay, so now we need to find an equation. What we need to look for when we look for an equation is that it contains the variable we want to solve for, and it contains and we have enough information to fill everything in on that equation other than the variable that we're solving for. So let's see. The first problem I can't use because the first equation I can't use because we don't have the final velocity of the car, so I'm not going to use this equation. The next problem still has the same problem. It requires me to know the final velocity of the car in order for me to find the answer. Also, it doesn't include acceleration, which is what we're looking for. The last equation has the same problem, that it requires us to know the final velocity, and we don't know that. This equation looks pretty good. We know the displacement, we know the initial velocity, we know the time, and we know that we're looking for acceleration, which is the only thing in this equation that we don't know. So let's use this equation to solve our problem. So we selected S equals ut plus 1/2 at squared. Okay, so next I'm going to solve for acceleration since that's what we're looking for. S minus ut divided by, let's see, multiply by 2, divide by t squared, and I've solved for a. Okay. Next I can plug in my values. So I know that this value is 0 for u, so I know this whole term will drop out because it's 0 meters per second. So I am left with 2s over t squared equals our acceleration. So 2 times s, which is 110 meters, divided by t squared, which is 5.21 seconds squared. I solve for that, and I get 8.1. And then my units, I can look to check. I can look at my units to check to make sure that I did the right thing in my problem. So because this is an acceleration problem, I would expect to get my answer to be in meters per second squared. And we see from our units in the problem, I have meters over seconds squared. So by doing a little unit analysis like that, I can check my work, and I know that my acceleration is 8.1 meters per second squared.